this video, I am going to explain Zwitter ions. Before going to study about the Zwitter ion, we want to know the basic structure of an amino acid. This is the basic structure of an amino acid. Here we can see a central carbon which has tetravalency. The four different groups are attached to this carbon. One is hydrogen, another is an alkyl group, one NH2 group and one COOH group, one carboxyl group. So this amino acid contains a tetravalent carbon in which the four different groups are attached. One is an alkyl group, that is R, one is an amino group, one is carboxyl group and the other one is hydrogen group. So this is the basic structure of an amino acid. Now let us see the formation of Zwitter ion. When an amino acid dissolved in aqueous solution, what happens is the H group, the hydrogen group of this carboxyl group is transferred to the amino group of this amino acid. The hydrogen group of this carboxyl group is transferred or shifted to the amino group of this amino acid. So what happens is the amino group becomes NH3 plus. Here, look here. Here the amino group is becomes NH3 plus and the carboxyl group becomes COO minus. So here the NH2 accepts a proton from the carboxyl group. So the NH2 group is the proton acceptor and the COOH group is the proton donor. Now look here this molecule. Here we can see both the positive and negative charges. Both the positive and negative charges is present in the same molecule. So this molecule is known as dipolar ion. Dipolar ion. Both poles are there, so it is known as dipolar ion or Zwitter ion. Zwitter ion. So I will explain once more. When an amino acid dissolved in aqueous solution or water, the hydrogen group of this carboxyl group is shifted to the amino group of this amino acid. So what happens is the NH2 becomes NH3 plus. Similarly, the COOH becomes COO minus. So both the positive and negative charges are there in the same molecule. So both poles are there, so it is known as dipolar ion. Dipolar ion or also known as Zwitter ion. Zwitter ion. In this molecule you can see both positive and negative charge, so it is also known as a neutral molecule. Both the positive and negative charge is there in the same molecule, so this is also known as neutral molecule. Neutral molecule. Since they are neutral molecule, their charge is 0. The net charge is 0 because it contains both positive and negative charge. So the total charge becomes 0. Now let us see what's happening to the Zwitter ion in two different conditions. One is acidic condition and another is basic condition. So first we look into the acidic condition. In acidic condition, what happening is, the acidic condition means there is more H plus concentration or the hydrogen ion concentration is more or the pH is more. That means by this carboxyl group, the hydrogen ions will be taken up. That is, the hydrogen ions will be taken up by the carboxyl group and forming COOH. It will become COOH. In the acidic condition, there will be the hydrogen concentration more. So, the carboxyl group CO minus group will taken up the H plus from the medium and it is converted to COOH. It becomes COOH. So, the charge is, the overall charge here is positive. So, the overall charge here is positive. I will repeat. In the acidic condition, this is the Zwitter ion. So, in the acidic condition, the H plus concentration is more. So, in the acidic condition, the H plus is taken up by this carboxyl group. The H plus will be taken up by the carboxyl group and it becomes COOH. The CO minus will become COOH. So, the overall charge becomes positive in this molecule. So, this is a cation. The overall charge is positive, so it becomes a cation. So, when we are doing electrophoresis, the positively charged cation, this positively charged cation moves to the cathode. The negatively charged electrode cathode. So, the overall charge is positive here. So, this in electrophoresis, this positive charged cation moves to the cathode, the negatively charged electrode cathode. Now, let us consider the basic condition. In the basic condition, the OH concentration is more. The OH minus concentration is more. So, when we kept the Zwitter ion in the basic condition, what happens is the H plus from the NH3 plus. H plus from the NH3 plus is moves out and combines with OH for releasing water molecule. Water molecule will be released. So, it becomes NH2. So, the overall charge will be negative. I will explain once more. In the basic condition, the OH minus concentration is more. So, the H plus from the NH3 plus moves out and combines with the OH, releasing H2O. Water molecules will be released and the NH3 plus becomes NH2. So, the net charge here is negative. So, this is known as anion. The net charge is negative, so this is known as an anion. When we are doing the electrophoresis, these molecules will move to the anode, the positively charged electrode anode. So, in the electrophoresis, this anion moves to the anode electrode. So, in the acidic condition, the Zwitter ion acts as proton acceptor. Because here the COO minus accepts the hydrogen. So, in the acidic condition, the Zwitter ion acts as the proton acceptor. But in the case of basic condition, the Zwitter ion acts as the proton donor, because from the NH3 plus, one H plus is removed. That is given to the OH. So, in the acidic condition, the Zwitter ion acts as proton acceptor, and in the basic condition, the Zwitter ion acts as the proton donor. So, the Zwitter ion can act as proton donor and acceptor. Proton donor and acceptor. So, the Zwitter ion is amphoteric. It shows both. It acts as both proton donor and acceptor. So they are known as amphoteric substances or ampholites. 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 So the Zwitter ion can act as both proton donor and proton acceptor. So these molecules are known as amphoteric substances or ampholites. So what are Zwitter ions? Zwitter ions are molecules which contain equal amount of ionizable groups of opposite charges. So the net charge is 0. The net charge is 0. So the Zwitter ions are molecules which contain equal amount of or equal number of ionizable groups of opposite charges. So the net charge becomes 0. So they are known as dipolar ions. Dipolar ions or neutral molecules or hybrid ions. Hybrid ions. So this is the property of an amino acid that can act as a base and an acid. Base and an acid, and they are known as amphoteric substances. This is about the Zwitter ion. Thank you.